So this one is 5.13, where we have to do standard form for smaller numbers. Means all these numbers are lesser than 1. Previously, we did all of this is larger than 1, larger than 10. So we need to multiply by 10 to the power of a positive number. So if you want to do a standard form for smaller number, technically it's a division. It means that if I want to write, let's say 0.52, how do I write this? This is actually equals to, if I write it in fraction, is 52 over 100, correct? So when I write in fraction, it looks like this. And then 0.52 is equals to 52 divided by 100. So 0.52 is actually 52 divided by, if I write 100 in the power of 10, is 10 to the power of 2, right? 10 times 10 is 100. So it's divided by 10 to the power of 2. If you follow the law of indices, is when you write, if you write things like this, 0.52 is equals to, you write things like this, 52 over 10 to the power of 2, the same thing as this one here, which is a division. If it's at the bottom here, we can actually move it to the top. But when we move it to the top, like the other time I told you about heaven and hell, or where it's supposed to be, where it's supposed to belong to, if you remember, that was in our law of indices class. So if it belongs at the bottom, but if you put it to the top, it will become a negative value. So it will change to 0, it will change to 52 multiplied by 10 to the power of negative 2. Will be equal to this. But this is not what I want, right? Because I want it to be standard form. Make sense? So if I want it to be standard form, I need to change the 52 to 5.2. Then this is times 10. Then times 10 to the power of negative 2. Then we have to add them together because this is power 1, this is power negative 2. Then we add them together, we get 5.2 times 10 to the power of negative 1. So this one is standard form for 0.52. This is equals to this. This looks a little bit complicated, but actually that it is fairly simple. This is the explanation of what actually happens. But if we want to do it here, it's actually quite easy. We just have to calculate how many zeros there are in front. If there are 3 zeros, then it's to the power of negative 3. It is not a coincidence, but it is always true. So if we look at this one here, the next one, we got 1, 2, 3, 4, 5, 6, 7. 7 zeros here. So it's 10 to the power of negative 7. Quite easy. So we just need to calculate how many zeros there are. But if it is 0. Let's say 0.00204, I do not need to calculate this 0. This 0 is irrelevant. I just need to calculate from the largest value, whatever's on the left. So here is 1, 2, 3. So I can actually just write 2.04 times 10 to the power of negative 3. This is the standard form. So if you want to do standard form this way, it is easier for the negative value. You cannot do it for the positive ones because positive ones, you need to move to decimal. Here, actually, you're also moving the decimal. So if we're looking at how we want to move the decimal, we just look at this one again, 0.0204. If you want to move the decimal, let's enlarge this. We need to move the decimal to here. This is the point where we need to move it to. So let's try to move it from decimal point. We're moving to the right now. For the positive one, we're moving to the left. So here we're moving here 1, 2, 3. So the 3 jumps here is the one that we need to look at. So if it's 3 jump to the right, then it's negative. So 10 to the power of negative 3. As opposed to this, decimal place is here, but I need to move it here. This is the positive version. So I need to move it to the left. If I'm moving it to the left, then it is times 10 to the power of a positive number. 1, 2. So this is 2.04 times 10 to the power of 2, because there are 2 jumps. This one, however, is 10 to the power of -3, because there are 3 jumps to the right. This is 2 jumps to the left. Okay? This counting zero method, you cannot use it for the positive ones. You can only use it for the negative. Then again, if we're looking at here, if it is a multiplication, then we need to just multiply 2 and 3, multiply, get 6. 10 to the power of -3 plus 10 to the power of -7, we get 10 to the power of -10. Because law of indices states that if it's a multiplication, we need to add the power. Okay, so if we look at, then if it's okay, if it's a division here, you use the same law of indices. So let's look at number 3E here. So we're going to do the same for the numbers. So 9 divided by 4.5 is one section. The other section here will be 10 to the power of 17 divided by 10 to the power of -16. Okay, if you follow the law of indices here, division is minus. So what we will do here is for the power, we will do a minus. So 10 to the power of 17 minus -16. So go back to your normal plus or minus thing. Negative minus minus a negative, it changes to a positive. So 10 to the power of 17 plus 16. Here we will get 10 to the power of 33. So this one here, 9 divided by 4.5, we get 2. So the answer is 2 times 10 to the power of 33. Okay, this one comes here. Okay?
Yeah, okay.
Then if we are doing this one, we also need to make sure that it is the same. So since it's a minus, we need to make sure that the value is the same. So like I said, if you move decimal to the right, then it will be a negative. If you move the decimal to the left, then it will be a positive. So for here, I will want to make it to the largest possible value. So this is -1, so I need to change this to -1. So I'm moving it to the left, because this one need to +1. So I move this to the left, I get 3.2 times 10 to the power of -1 minus 0.32 times 10 to the power of -1. So when they are the same, then I can actually take this one, because they are same measurement. I can take 0.32 and 3.2, 3.2 minus 0.32. The power doesn't change anymore. So I'll get 2.88 times 10 to the power of -1. This one and this one, you don't touch because it's just a measurement. It is not like a multiplication where you need to do it for that. This one is just you need to make sure that they are of the same power, then we can only solve it. So this one here, same power, then we can solve it. I move the decimal to the left in order to add one here. So for this one, if I need to solve it, this is 10 to the power of 3 plus 5.6 times 10 to the power of -1. So I need to change this. I need to move the decimal to the left how many times? Until 3 means we need to +4. We need to move 4 times. So 1, 2, 3, 4. Then you solve it as it is by adding 7.01, adding 0.125.6. We move it 4 times. 1, 2, 3, 4. So we'll get 0.000. We get 0.00056. Then 7.01, just add this number. Then you just maintain 10 to the power of 3.